So I have shared my screen with you guys. Let me know if this it's visible to you. Okay. And I welcome you all in this session of geometrical optics. Make sure that I'm audible to you, everyone. I know that you guys are having your pre-board examination and you are going to prepare for them, and that's why the attendance is getting low. But this would ultimately help you in your examination notes. This is a kind of revision you can consider. Okay. So try to be attentive in the class and yeah, try to be responsive. Now, let's just start with the session. So it's a ray optics final session, not final, the second last session. In this session, we are going to study about refraction, lenses, lens formula, lens maker formula, power of lens, cutting of lens, and silvering of lens, which means mostly we are dealing with the refraction part and the lenses. These formulas or these revision or this chapter, this part of the chapter is going to be helpful for you in your upcoming examinations also, which is pre-board. Now let's just get started with it. Now, same as reflection, we have studied reflection, what it is when the light strike on a shiny surface, it reflects back or it bounce back on the same medium with the no change in velocity. So velocity will be same, and the laws of reflection says that जो भी angle of incidence होगा same angle of reflection will be there. But refraction is a different phenomena. Suppose that surface on which the light strike is not a shiny surface. Okay? It's a transparent surface. Not a transparent, it's transparent surface. So what you will find that when light enters in that transparent medium, it bends away, it bends toward the medium or bends away from the medium. Now, this phenomena of refraction, which is the bending of light when it is passes through one medium to another medium, is nothing but refraction of light. Okay. This bending of light depends on the optical density of the medium. Like if light feels, not we, if light feels that this medium is optically dense, then it will bend toward the normal. And if it is find that this medium is optically rare, then the light will move away from the normal. Okay? This bending process is because of the density difference that I have mentioned here also. Because of the density, and this density is nothing but the optical density. Like in general, oil is lighter than water because oil can float on the water surface. But according to light, oil is much denser than the water. Okay. So if you see here, there is a normal line, line of normal. And here we have a surface which is called the boundary. This is nothing but the boundary, which is the interface between these two medium. This medium is air and this medium is glass. So obviously glass is optically less dense, optically more dense than air. So when light, देखो यहाँ पे, when light incident on this surface and penetrate into it, you will find that it is bending towards the normal. Otherwise, it should move in this direction, but it is bending towards the normal. Okay. So this is happening because of the refraction. Similarly, if you reverse the way of it, if you reverse the way, suppose the light is coming from glass and going into the air. So what you will find out when light strike at this point and when it penetrate into the air, you will find out that it moves away from the normal. Why? Because air is less denser than glass. So whenever the light travels from rare medium to denser medium, the light bends toward the normal. And whenever the light passes from denser medium to rare medium, it move away from the medium. Okay. So you can mention it here, denser to rare, move away from the normal, move away from the norm. Got it? Normal is the line perpendicular to both the surfaces. And its opposite is nothing but rare to denser. If it move rare to denser, then you can see it will move towards the normal. Okay. This picture you can keep in your mind. Now, what is the laws of reflection we should be based on this reflection phenomena? Now, firstly, we will studying this laws of reflection. Then we go to the total internal reflection. What is that? We will also elaborating. Now, laws of refraction state that first of all, incident ray, refracted ray, and normal to the interface of two medium at the point of incident all lies in the same plane. So ये तो satisfied होती है condition. सबके सब सेम प्लेन में. ठीक है. ऐसा नहीं है कि कोई रे इधर से आ रही है, ऐसे आ रही है, परपेंडिकुलर टू द दिस सरफेस. This ray is in the same plane in which the medium is placed. And incident ray is this. This is the incident ray. And after refraction, this ray will become refracted ray. Refracted ray. ठीक है. क्लियर है. नाउ म्यू वन, यहाँ पे आप अगर देखो, so second law is says that the ratio of sine of the angle of incidence, which means sine I, to the sine of the angle of refraction, which is sine R, is constant. And this is also known as Snell's law of refraction, which means it is saying that the ratio of sine I upon sine R is equals to a constant. And this constant is nothing but the refractive index of medium. And this refractive index is relative refractive index, not the absolute. So to apply this, what we will consider that here the refractive index of air is m1 and this particular material is m2. So how you can apply this Snell's law? You will write mu1 sine I is equals to mu2 sine R. Multiply the refractive index of this material with the angle of incidence, which is the incident ray making, with the normal on that medium. तो यहाँ incident ray air में है, mu1 refractive index में है. So it is written as mu1 sin I, which is also equals to mu2 sin R. Ultimately, we will find out sin I by sin R is nothing but mu2 by mu1, and mu2 by mu1 is constant because mu1 is already fixed, mu1 is already fixed. But this ratio mu2 by mu1 is nothing but termed as 1 mu2, which is refractive index of medium 2 with respect to medium 1. So 1 mu 2 का मतलब refractive index of 2 with respect to 1. So 1 mu 2 is equals to sin I upon sin R, which is ultimately equals to mu, and which is nothing but a constant. ठीक है. So that's how you are going to apply the law of reflection. Now, what is total internal reflection? We know that if this is air, let's say, sorry, this is glass, and here the another medium is air. So glass is dense, This is the denser medium and this is a rarer medium. Okay. So we know that when light move from incident ray from the denser medium to the rarer medium, it moves away from the normal. So it moves away from the normal. Let's say this angle is I1. So this angle is nothing but R1. Now if I increase the incident angle, let's say this is I2, this is I1, then ray will move more away from the normal. It will bend more. So you will see at a particular instant of time, at a particular instant of the value of I2, this ray grazes over the boundary, which is it is not going to the medium 2, which is air also, and not going on the medium of glass. So it's on the surface. It's grazes the surface. इसे क्या बोलते हैं? Grazing of surface. Grazing. ठीक है. If you increase more, if you increase the value more of I incident angle, if you increase beyond this limit also, then you will find that no part of the reflected ray going into the rarer medium, all the part is assumed that it is being reflected with the same angle. Okay. Now, what is the critical angle here? So, critical angle here is the angle after which the ray, the minimum value of the angle after which, if I increase the value of incident angle, the ray will not come to the rarer medium. It will be totally reflected. That is why this phenomena is termed as total internal reflection. So critical angle, if I write here, is that, so critical angle is I2. So let's say the medium of glass is mu, and we know that the air of, if we have air as a medium, the refractive index of air is 1. So if I apply Snell's law over here, it will become mu of glass, which is mu, sine, let's say this I2 is defined as C, because it is a critical angle. Mu sine C is equals to 1, which is the value of air, sine into refracting angle will become what? This one, 90 degree. Good evening. So sine 90. इसमें किसी को डाउट है? देखो, when we throw the light at an angle C, it grazes the surface after refraction. Grazing कर रही है तो नॉर्मल से कितना एंगल बनाया? 90 डिग्री. So that's why 1 sin 90, which is mu sin r. R here is 90 degree. Mu is 1. So we can say that sin C here is nothing but 1 upon. So critical angle of a medium is given by sine inverse 1 upon. Got it? I hope that you have understood this. Laws of reflection we have talked about. Now, let's just talk about lenses. What is lens? So lens is nothing but a transparent medium. Lens is also transparent medium, but it's a special type of transparent medium. Okay. And what is that? It's like a magnifying glass. If you want to see a magnifying image, yeah, please, I'll show you this one. When you note it down, let me know. Okay. GNV drawing. Okay. It's very good that you are noting it down. You're taking notes of it. So a lens is nothing but a magnifying glass, or we can say the transparent glass that concentrate. If you see, this is the incident light. So what this piece of glass is doing, it is converging the rays. It is also converging the rays, and it is diverging the rays. Okay, the rays diverge from each other. So glass is that piece of, sorry, the lens is that piece of glass or magnifying glass which disperses the light ray when passes through them by refraction. Because it's a transparent medium, so the refraction is taking place there. So a lens is a transparent piece of glass that concentrate or disperse the light ray when it passes through them by refraction. तो किस phenomena से, which phenomena is responsible for this dispersion or concentration? Is refraction. Okay. Now in this part it is converging, and in this part it is diverging. Okay. You will find out what this particular glass or this particular lens, which usually converges the rays after refraction, that is termed as convex lens. Okay. So this part is termed as double convex lens because we have two surfaces here. Here only one surface is convex, other surface is plane. So these types of lenses is termed as plano-convex lens. And here, this is also termed as, you can write it as convexo-concave lens. And the second name is positive meniscus, which means that the more curved part we are having here is behaving as a concave lens, convex lens. तो इसका ये पार्ट क्या होगा, कन्वेक्स की तरह बिहेव करेगा एंड ये कनकेव की तरह बिहेव करेगा. ठीक है. Similarly, on the other side, if you will see, if a lens diverges the ray, that will termed as concave lens. So here double the surfaces we have. It is double concave lens. This is plano concave lens because one of the surface is plane, and second is negative meniscus. तो यहाँ पे भी ये जो major portion है इसका, that will be this one is acting as a concave lens. So इसे हम क्या बोलते हैं, कॉनकेवो कॉन्वेक्स लेंस. ठीक है. कंडीशन क्या है लेंस होने के लिए, वन ऑफ द टू सरफेसेस मस्ट बी कर्व. एक सरफेस को कर्व होना ही पड़ेगा. ठीक है. सो वी यूजुअली स्टडी टू टाइप्स ऑफ लेंसेज इन दिस चैप्टर, विच इज convex lens and concave lens. One of more trick to remember these lenses is, you will see at the middle portion, if the lens is getting thicker when you are traveling downside from both the side, from the end of the lens, if you are traveling at the mid part, if the mid part is getting thicker, then that lens is convex lens, and if the mid part is getting thinner, that is the concave lens. That's the simple discrimination between them. Now some terms related to lens here. So here we have this, let's say this is termed as O. So O here is defined as optical center. Optical center of lens. Optical center से क्या मतलब होता है? Whenever the light passes through this optical center, it will not diverge. Which means if a light ray come like this, it will move like this. It will not converge or diverge. Okay. So this is the property of this optical center. It is same as the pole in the mirrors. Okay. So light does not converge or diverge at this point. ठीक है. Clear हुआ. Now if you compare it with lens, or sorry, mirror, in mirror we have only one side which is responsible for the reflection. So this is also a part of this is a part of sphere. So we usually write down the center of the sphere. So here also, since here we also have two curved part, so what we can say, These two curved part is nothing but a part of two sphere, one of like this and second of like this. So एक जो sphere है उसका center इस side होगा, one of the center is lies on this side and one of the center lies on the opposite side, let's say this. ठीक है, clear हुआ? These are the center of curvatures. So C1 and C2 is what here? C1 and C2 are center of curvature. Clear? Now, this is the parallel beam of light and this is nothing but the principal axis. We have told you about in the mirror. This is principal axis. Now, when a light ray moves parallel to the principal axis, so this concave lens, sorry, this convex lens try to converge this ray. So after conversion, wherever it hit the principal line, that is the focus. And this is the first focus, or you can say principal focus. It has another name also, primary focus. Okay, but let's say this light ray is coming from this side. So after reflection, it will cut the principal axis. So this side may, this is also focus. So this is termed as F2, which is nothing but secondary focus. Got it? So F1, F2 are the primary and secondary focus. I have told you that how these focus are formed. If you take your incident ray from left to right, then primary focus, it will focus on the primary focus. And if you take your incident ray from right to left, it will focus, the lens will focus it on the secondary focus. Okay, clear? Now, this distance is termed as from the optical center. देखो C1 को मेजर करने के लिए you have to move in this direction. You are moving in this direction, left, right to left. So this is, let's say, R1. And to measure C2, you are moving in the right to left. So it is R2. I'm going to ask you that which one you have to take positive, because I have already told you about the sign convention. Okay? So I hope you got it what I have told you. This F1 is nothing but the primary focus. And F2 is nothing but the secondary focus. Very good, Harish. So, very good, Harish. Now, lens formula, same as mirror formula we have. But in the mirror formula, we are having 1 by V plus 1 by U. Here we are having 1 by V minus 1 by U equals to 1 by F. ठीक है? So, ये दोनों लेंस के लिए is applicable for both the lenses. Either the lens is concave or the lens is convex. तो दोनों के लिए applicable this formula. V, U and F we will decide according to the according to what? According to the question. अच्छा एक बात बताओ. If I take a concave lens, ठीक है, and if I draw a line, a light ray, incident ray, which is parallel to the principal axis, so it will diverge it. So it will never cut this axis. So we can say it appears to be coming from this point. Can we say that? This ray will appear to coming from this point. So can we assume it as a primary focus? Yes, we can. So this is the virtual focus of this particular lens. और आप देख सकते हो कि ये प्लस है, पॉजिटिव है, ठीक है, सॉरी नेगेटिव है, बिकॉज वी आर मेजरिंग इट इन द डायरेक्शन ऑफ रिफ्लेक्टेड रे. सिमिलरली इफ अ रे इज कमिंग फ्रॉम दिस पॉइंट, ऐसे कोई रे आ रही है तो इट विल डाइवर्ज हियर It will cut the it appears to cut the principal axis at this point. This is the secondary focus. Okay. Now magnification here is nothing but height of the image upon height of the object. You can use this same formula for the case of mirror also. In case of mirror also, magnification m is given by minus v upon v. Okay. Here it is v upon u1. Chalo. Now this formula is very important. You need to remember this formula. It is nothing but a lens maker formula, and it can be derived from this using this mirror formula, this lens formula. Okay. But we are not going through the derivation part. You just need to remember it that 1 upon f is the focal length, primary focal length of this particular lens, is equals to mu2 upon mu1. Mu2 is the medium of the glass of this lens. Mu1 is the outer medium, ट्रांसपेरेंट जो आउटर मीडियम है. सपोज इस साइड और इस साइड दोनों सेम ही, हमने एयर में ये लेंस रखा हुआ, तो लाइट इज कमिंग फ्रॉम द एयर गोइंग थ्रू अ लेंस ऑफ ग्लास एंड अगेन कमिंग बैक टू द एयर. ठीक है. सो इन दिस टाइप of situation, 1 upon f is given by mu2 by mu1 minus 1, 1 upon r1 minus 1 upon r2, where r1 and r2 is nothing but the radius of curvature of two curves. This is r1 and this is r2. Now you have to put down these according to the question. Either one of the positive, one of them is negative. So you can write that 1 upon f is equals to mu2 by mu1 is nothing but, if you consider that mu1 is air, if mu1 equals to 1, which means the lens we have placed in air, then 1 upon f is equals to mu minus 1, 1 upon r1 minus 1 upon r2. ठीक है. क्लियर है. नाउ for bioconcave lens, bioconvex lens, for biconvex lens, let's say r1 is equals to r2, then यही मान लेते हैं कि r1 और r2 सेम, but we know that the sign of r1 and r2 will be different. देखो r1 we have measured in this direction from right to left, और ये डायरेक्शन किसकी है, रिफ्लेक्टेड रे. तो r1 will be considered as what, negative, and r2 will be considered as positive because it is measured in the direction of incident ray. ठीक है. So here 1 upon minus 1 upon r1, which is r, minus 1 upon r. So you will find that it is coming out as 1 upon f is equals to mu minus 1, 2 upon r, which is, let's say 1 upon f is equals to minus 2 times, or you can say 1 minus mu, 2 times of 1 minus mu upon. Okay. Clear है. You can shift according to it. R1 is the radius of curvature of this side. Okay. Let me check it. Meanwhile, you can take the note of it. तो यहाँ पे ये C2 है और ये C1 है. ठीक है. इसलिए ये हो जाएगा R1 और ये हो जाएगा R2. तो ऑलवेज रिमेंबर C2 भी मेजर्ड इन दिस डायरेक्शन, राइट टू लेफ्ट. C1 भी मेजर्ड इन दिस डायरेक्शन. यही थोड़ा सा ग्लिच हो रहा था मुझे. ठीक है. तो यहाँ पे हम देखेंगे तो R1, which is 1 upon R1. R1 is in positive side and R2 is in negative side. So it will make 1 minus 1 upon R. So ये minus vanish out हो जाएगा बस, और कुछ. But you need to remember that you need to measure R1 in this way, in this direction. ठीक है. R1 is the center, sorry, radius of curvature of this part, this one, first surface. This is second surface. Okay. So for concave lens, कॉनकेव लेंस के लिए अगर आप करोगे तो इस सरफेस की जो रेडियस होगी यानी कि इस तरफ वो नेगेटिव होगी. R1 यहाँ पे नेगेटिव और R2 यहाँ पे क्या होगा, पॉजिटिव. ठीक है. तो 1/R1 जब आप करोगे तो ये नेगेटिव आ जाएगा. इसका मतलब इसका जो फोकस है वो नेगेटिव है, इसका फोकस क्या है, वो पॉजिटिव है. ठीक है. और वही हमने देखा भी था अभी. मैंने देखा था ना, F1 इज कमिंग इन दिस डायरेक्शन which is the direction of reflected rays basically. So F1 is considered as negative, but in case of this, the primary focus is coming on this side, which is the direction of incident ray, which is positive. तो इसका जो फोकस होता है दैट विल बी पॉजिटिव, कन्वेक्स लेंस का. और कनकेव लेंस का जो फोकस होता है वो नेगेटिव होता है. इसी हिसाब से हम इनकी पावर भी डिसाइड करते हैं. अभी पहले ये क्वेश्चन देखो आप. फॉर अ थिन कॉन्वेक्स लेंस ऑफ रेड आई, फॉर द थिन कन्वेक्स लेंस, ठीक है, कन्वेक्स लेंस, the radii of curvature are 15 centimeter and 30 centimeter respectively. The focal length is 20 centimeter. The refractive index of the material is. ये ये वाला जो पार्ट दिया ना 15 सेंटीमीटर, R1 is given as 15 सेंटीमीटर, R2 is given as -30 हो जाएगा ऑटोमेटिकली, F is given as 20 सेंटीमीटर और फोकस इसका क्या होता है, पॉजिटिव ही होता है. सो 1/F म्यू -1, 1/R1 -1/R2. एंड अभी हमने देखा था यहाँ पे R2 क्या होगा, पॉजिटिव. 1/F भी पॉजिटिव है तो 20 सेंटीमीटर -1. 1/R1 इज 15, 30. So it's exactly half of it. So it will become 1/20 mu -1, 1/30. 1/15 is 1/30 is exactly half of 1/15. Na? So this will cancel out. So ultimately what you are having is 1/2 times mu -1/3. Cross multiply it. Or what you can do, it will be 3/2 mu -1. Mu is coming out as 5/2. ठीक है. क्लियर है. देखो ये 1 इधर आ जाएगा. क्लियर हो गया. कोई मिस्टेक किया है क्या. 1.5. हाँ, आंसर तो 1.5 ही है, बट आई थिंक वी हैव डिड सम मिस्टेक हियर. जस्ट चेक. So focal length is 1/20. We have put it here. Mu -1, 1/R1 is 15 and 30. So it's 1/2 mu -1/3. Cross multiply will give you 2 mu -2 is equals to 3. 2 mu 3 plus 2 is 5. So mu is coming out as 5/2. According to me, mu is coming out as 5/2, which is 2.5. What the error we are doing here? If anyone remember? Yes, I do. मुझे पता चल गया कि हम क्या एरर कर रहे हैं. And we are doing the error with the sign of R2. R2 is -30 and we are putting it at +30. So it will become plus. Now we can say that this is 3/2 times of 1/30. ठीक है. This is 10. Again, let me do it again. 1/15 is 2 times of 30. Can we write it like this? 3/30. 1/20 mu -1. 3/30. This 1/0 will cancel out. 3 and 3 will cancel out. And then you will find mu is coming out as 1. हाँ, R2 is negative. So it will become 1 by 2 mu minus 1. 1 को इधर भेजेंगे तो म्यू विल बिकम 3/2 विच इज 1 पॉइंट. देखो इजी क्वेश्चन है, जेई मेन 2024 में है, तो ये फॉर्मूला बहुत इंपॉर्टेंट है. ठीक है, चलो पावर ऑफ लेंस के बारे में बात करते हैं. पावर इज नथिंग बट द एबिलिटी टू कन्वर्ज और डाइवर्ज. ठीक है. हाउ शॉर्टली a lens or a mirror is converging or diverging the ray, that is the power of that lens. मेरे पास ये लेंस है, ये डाइवर्ज करता है, सॉरी कन्वर्ज करता है, और ये दूसरा लेंस है, बट ये कन्वर्ज जो कर रहा है थोड़ा आगे जाके कर रहा है, तो हम क्या कह सकते हैं कि ये पहले कन्वर्ज कर दे रहा है, विच मीन्स इसके पास ज्यादा कैपेसिटी है टू बेंड द रेज. तो इसकी पावर क्या हुई ज्यादा. तो पावर इज नथिंग बट द एबिलिटी टू कन्वर्ज और डाइवर्ज द रेज, इंसिडेंट बीम ऑफ लाइट, नॉट बीन. बीन का क्या करेंगे वहां पे, ये बीम है. ठीक. सो एबिलिटी टू कन्वर्ज इज टेकन एज पॉजिटिव. ये क्या होगा, पॉजिटिव होगा. एंड एबिलिटी टू डाइवर्ज इज टेकन एज नेगेटिव. ये कन्वेंशन. ठीक है. मिरर की पावर क्या होती है, पावर ऑफ मिरर इज नथिंग बट 1 - 1/FM. FM यहाँ पे क्या होगा, फोकल लेंथ ऑफ मिरर है, विच इज गिवन इन टर्म्स ऑफ मीटर. सो इफ यू विल सी, ये वाला मिरर पकड़ो आप, ये कनकेव मिरर है, ये क्या करता है, देखो कन्वर्ज करता है, तो इसकी पावर पॉजिटिव आनी चाहिए. हमें पता है कि कनकेव मिरर की जो फोकल लेंथ होती है हम इसी तरफ मेजर करेंगे यहाँ पे, वो क्या होगी, नेगेटिव. व्हेन आई पुट इट हियर, इट विल बिकम -1/f, -1/f, विच इज प्लस, विच मीन्स जो कन्वर्जिंग मिरर है उसकी पावर क्या होगी, पॉजिटिव होगी, लेकिन फोकल लेंथ क्या होगी, नेगेटिव होगी. ठीक है. देखो यहाँ पे कनकेव मिरर क्या करता है, कन्वर्ज करता है, बट कनकेव लेंस क्या करता है, डाइवर्ज करता है. तो ऐसे याद रख सकते हो आप, ऑपोजिट है एक दूसरे. ठीक है. बट इफ FM is given in सेंटीमीटर, तो उसके लिए वैसे आप कर ही सकते हो एट द टाइम ऑल्सो, बट आई एम मेंशनिंग इट हियर इज -100/FM. You will write. The unit of this power of mirror is very unique, which is diopter. ठीक है. तो you will find when you, if anyone have put glasses like me, so they will measure the power of the lens here. So it is mentioned on your uh, the description, that is prescription which is given by the doctor. उसमें ये मेंशन होता है किस किस पावर का आपको लेंस लगा है. ठीक है. सो पावर ऑफ लेंस इज नथिंग बट 1/FL. सिमिलरली इफ FL is given in centimeter, so you will be using this formula. If FL is equals in centimeter. कन्वेक्स लेंस के लिए PL क्या होता है, पॉजिटिव होता है, पावर इज पॉजिटिव. कनकेव लेंस के लिए पावर क्या होगी, नेगेटिव, क्योंकि वो डाइवर्ज करता है, सिंपल सी बात. ठीक. Similarly, this analogy you can use for this mirror also. For concave mirror, power is positive. For convex mirror like this. So it is diverging, so power is negative. ठीक है. चलो, थिन लेंस इन कॉन्टेक्ट. अब क्या करा, हमारा मन नहीं भरा तो हमने क्या करा, लेंस को एक साथ जोड़ दिया. नाउ व्हाट विल हैपन, व्हाट विल हैपन, the focal length will disturb now because ray has to pass through medium now, or two lenses. ठीक है. सो फोकल लेंथ विल डिस्टर्ब, एंड हाउ इट विल डिस्टर्ब, तो इफेक्टिव जो पावर होगा, पावर भी डिस्टर्ब करेगा, कि पावर इज अल्टीमेटली डिपेंडिंग ऑन फोकस. मोर द फोकस, मोर फोकल लेंथ का मतलब वो बहुत दूर जा करके कन्वर्ज कर रहा है, तो इसलिए पावर क्या हो जाएगी, लेस, क्योंकि इनवर्सली रिलेशन. ठीक. सो इफेक्टिव पावर ऑफ द लेंस ऑफ दिस सिस्टम, दिस इज L2, दिस इज L1, सो यू विल फाइंड 1/F1 + 1/F2, कितने भी लेंस हो. सो इट इज गिवन बाई 1/F इफेक्टिव सिग्मा 1/F आई. अब आई कितना भी हो सकता है, 1 से लेकर के n तक. तो क्या करना है, 1/F1 + 1/F2 + 1/F3, बट रिमेंबर टू यूज अ साइन कन्वेंशन ऑल्सो. सो फॉर L2, दिस कनकेव लेंस के लिए फोकस इज नेगेटिव, सो यू विल बी यूजिंग -1/f। ठीक है। बट एक क्वेश्चन क्या अराइज हो रहा है आजकल कि इफ द लेंस इज सेपरेटेड सब डिस्टेंस पे, देन टेल मी व्हाट इज द फोकस। सो इट्स नथिंग बट, अगर मेरे पास दो लेंसेज ही हैं चलो, बट दे आर बीइंग सेपरेटेड by some distance, let's say d, so what is the focal length or the power of this combination? So focal length is 1 upon f1 plus 1 upon f2 minus d upon f1 f2. This extra term you have to subtract from this. So power effective is 1 upon. Got it? Now let's just do this question. A plano convex, it's convex. So many typing errors. A plano convex lens fits exactly into a plano concave lens. ठीक है। प्लेनो कॉन्वेक्स लेंस पहले तो बताओ कैसा होगा। ऐसा होगा प्लेनो कॉन्वेक्स लेंस। प्लेनो कॉनकेव लेंस कैसा होगा? प्लेनो कॉनकेव लेंस ऐसा होगा। ठीक है। अब ये क्या है, ये इसमें फिट कर रहा है एग्जैक्टली exactly. ये मेरा प्लेनो कनकेव लेंस है, एक साइड प्लेन है दूसरी साइड कर्ड है, और इसी में ही मेरा क्या है, ये वाला। अभी दिखाने के लिए थोड़ा सा दूर बना रहा हूँ। ये प्लेनो कनकेव, अब दोनों के दोनों फिट हैं एक दूसरे में। सो अल्टीमेटली दे आर लुकिंग लाइक अ ग्लास स्लैब, लाइक दिस। बट अभी ग्लास स्लैब तो हो जाता, लेकिन यहाँ पे मीडियम जो है वो डिफरेंट। एक का मीडियम म्यू 1 है, दूसरे का मीडियम। सो म्यू 1 एंड म्यू 2 इज द रिफ्रैक्टिव इंडेक्स। ये तो क्वेश्चन में भी मेंशन है। ठीक है। आर इज द रेडियस ऑफ कर्वेचर ऑफ द कर्ड सरफेस। सो कोई सी भी जो भी कर्ड सरफेस है, देखो सेपरेटली करते हैं ना। इस वाले की जो रेडियस ऑफ कर्वेचर है वो भी कितनी है, आर है। और इस वाले की जो रेडियस ऑफ कर्वेचर है वो भी कितनी है, आर है। तो अब क्या करना है, रेडियस ऑफ कर्वेचर ऑफ कर्व सरफेस, देन फाइंड द फोकल लेंथ ऑफ दिस कॉम्बिनेशन। तो फोकल लेंथ के लिए 1/f इज इक्वल टू 1/f1 प्लस 1/f। अब देखो हमें तो इसका भी नहीं पता कि प्लेनो कनकेव लेंस की फोकल लेंथ क्या होती है। सो प्लेनो कनकेव की करते हैं पहले। देखो प्लेनो कनकेव की कैसे करेंगे ना, बाय यूजिंग लेंस मेकर फॉर्मूला। μ-1 1/r1 माइनस 1/r2। अब देखो पहली सरफेस तो ये है प्लेन, दूसरी सरफेस कर्ड, और दूसरी सरफेस का आर जो है वो पॉजिटिव है। बट पहली सरफेस का आर कितना है, कोई बताएगा मुझे? दिस प्लेन सरफेस के लिए रेडियस ऑफ कर्वेचर क्या होगा? सबसे बुद्धिमान बताऊंगा उस स्टूडेंट, मोस्ट इंटेलिजेंट स्टूडेंट विल आंसर दिस क्वेश्चन, एंड लेट्स से हु इज द इंटेलिजेंट वन। लेट्स सी। नो वन हैज आंसर्ड यू। चलो भाई, मुझे एक और टॉपिक भी पढ़ाना है, तो बताओ। देखो नो वन हैज आंसर्ड। चलो मैं बता देता हूँ। प्लेन सरफेस को मैं मान सकता हूँ, ये जो प्लेन सरफेस है, दिस इज द प्लेन सरफेस, ये किस सर्कल का पार्ट है? तो ये बहुत बड़े सर्कल का पार्ट होगा, तभी तो ये प्लेन दिख रहा है। तो इसका जो सर्कल होगा वो बहुत बड़ा होगा। बहुत बड़ा मतलब कितना बड़ा? तो इनफाइनाइट रेडियस का सर्कल। तो जो R1 की वैल्यू होगी यहाँ पे वो इंफिनिटी होगी, R2 की वैल्यू कितनी होगी, प्लस आर। तो 1/f इज इक्वल टू μ-1। 1/r1 इज व्हाट? इन्फिनिटी। और इन्फिनिटी भी कैसा, माइनस इन्फिनिटी। ठीक है। एंड दिस इज प्लस आर, सो इट विल बिकम -1/r। ठीक है। क्लियर है? -1/इन्फिनिटी इज जीरो। So 1 upon f1 that you are getting here is mu minus 1 into minus 1 upon r. ठीक है, क्लियर है? Is it clear to everyone or not? Let me know in the chat box. अच्छा, वी हैव इन्वर्टेड इट। तो ये जो प्लेनो कनकेव होता है ना, वो ऐसा होता है, इस तरफ से शुरू होता है। तो बस कुछ नहीं होगा, बस ये माइनस वैनिश आउट हो जाएगा यहाँ। ये R1 अब मेरी क्या हो जाएगी? R1 इज प्लस आर एंड R2 इज इंफिनिटी माइनस इंफिनिटी। ठीक है, सो इट विल बिकम 1 अपॉन प्लस 1 अपॉन आर माइनस 1 अपॉन माइनस इंफिनिटी। सो अल्टीमेटली इट इज दिस। नाउ फॉर दिस वन, इसके लिए कैसे करेंगे? तो इसके लिए फर्स्ट सरफेस इज दिस, सेकंड सरफेस इज, you can calculate it. I'm doing it directly here. One, it is 1 upon infinity minus 1 upon, ठीक है, क्लियर हुआ? अब देख, इसका जो R2 होगा वो क्या होगा? इस तरफ होगा, नेगेटिव साइड में। तो R2 will be plus here. So 1 upon F2 is also what? Mu minus 1, 1 upon R. अब देखो, इस फॉर्मूला में रख दो इसे, it will be coming out as R upon mu minus 1, R upon mu minus 1. And this mu's are also different. It's for first case this is mu1, for second case this is mu2. तो यहाँ से जो भी आंसर आएगा that is the final focus. ठीक है, क्लियर है? नाउ कटिंग ऑफ लेंस। भाई मैंने लेंस लिया, कनकेव लेंस, बीच से कट कर दिया, तो मुझे क्या मिलेगा? इफ आई ड्रॉ अ कटिंग लाइन परपेंडिकुलर टू द प्लेन, ठीक है, परपेंडिकुलर टू द प्रिंसिपल एक्सिस। प्लेन पे तो ये है ही, लेंस के प्लेन के साथ ही आ रही है, बट परपेंडिकुलर टू द प्रिंसिपल एक्सिस। तो क्या होगा? दोनों के दोनों जो लेंस होंगे विल बी कन्वर्टेड इनटू प्लेनो कनकेव, प्लेनो कॉन्वेक्स लेंस, इफ इट इज अ कन्वेक्स लेंस। और अगर मैं यही काम किसके साथ करूं? कनकेव लेंस के साथ करूं, तो आई विल गेट टू प्लेनो कनकेव लेंस। अब देखो, प्लेनो कनकेव लेंस के लिए फोकस निकालना इज वेरी इजी पीजी फॉर यू, बिकॉज वी कैन यूज अ लेंस मेकर फॉर्मूला हियर। Got it? So when we are using this formula, we have used lens maker formula here. Mu minus 1 upon r. 1 upon f1 will become what? 1 upon r1. देखो r1 इसकी है, इस तरफ जाएगी तो पॉजिटिव हो जाएगा। 1 upon r1 माइनस माइनस इंफिनिटी। ठीक है, सिमिलरली यू कैन डू फॉर फोकस f2, but ultimately what is the meaning here? f1 is reducing, f1 is equals to 2 times of f, which means after cutting the lens perpendicular to its principal axis, focus will double. फोकस डबल होने का मतलब क्या है? फोकल लेंथ, इसकी जो पावर है वो क्या होगी? घट जाएगी, डिक्रीज हो जाएगी। ठीक है, बिकॉज अल्टीमेटली पावर इज नथिंग बट 1 अपॉन एफ। नाउ, और इसी केस में अगर मेरे पास ये लेंस है, लेट्स से दिस इज द लेंथ, इन आई कट इट लाइक दिस बाय दिस, तो मेरे पास कैसा लेंस बचेगा? ये लेंस बचेगा। सो इनकी भी फोकस एफ ही रहेगा, इसका भी फोकस एफ ही रहेगा। फोकस विल नॉट डिस्टर्ब इफ आई कट इट पैरेलल टू द प्रिंसिपल एक्सिस। ठीक है, क्लियर है? और एक बात भी आप याद रख सकते हो, अगर आपके पास ऐसा कोई लेंस है और उसमें तीन अलग अलग मटेरियल है, म्यू 1, म्यू 2, म्यू 3, तो वो पूछता है कि ऑब्जेक्ट, एक ऑब्जेक्ट है तो उसकी कितनी इमेज मिलेगी? तो जितने मटेरियल है ना उतनी इमेज मिलेगी। ठीक है, नंबर ऑफ इमेजेस विल बी 3। नाउ सिल्वरिंग ऑफ लेंस। व्हाट इज सिल्वरिंग ऑफ लेंस? Silvering of lens is nothing but we have a lens, we silvered one of the surface. So when we silver that surface, the light will not pass through that surface. So ultimately we convert a lens into a mirror. So silvering is a process when we convert the lenses into mirror. So mirror, The lens will behave like a mirror because only reflection will take place. Got it? So focal length of equivalent mirror is given by 1 upon f is equals to minus 2 times 1 upon fl minus 2 upon fl. Fl is nothing but the focal length of lens. Focal length of lens. And fm is equals to focal length of mirror. Of mirror. Got it? सपोज आपके पास ये एक सरफेस है, प्लेनो कनकेव लेंस ले रही है, और इसकी यही सरफेस आपने सिल्वर कर दी, तो अब ये कैसा बिहेव करेगा? इट्स बिहेव लाइक, जो रिफ्लेक्शन होगा वो तो इस सरफेस से होगा ना, तो इट्स बिहेव लाइक अ कॉनकेव लेंस. ठीक है. बट अगर ये वाली सरफेस के बजाय ये वाली सरफेस कर दी सिल्वर, तो इट इज बिहेविंग लाइक अ प्लेन मिरर. ठीक है. क्लियर है? सो अकॉर्डिंग टू द सिचुएशन यू कैन कैलकुलेट द वैल्यू ऑफ इक्विवेलेंट फोकस, और जब आपको फोकस मिल जाएगा तो यू कैन इजीली कैलकुलेट द व्हाट पावर. ठीक है. So I have launched a poll to mark your attendance. Please do participate in that poll. If anyone has any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care of yourself. And always, like everybody has to answer in this poll. Each and every time I'm repeating this. Now, this time not. Okay. Try to answer all of the question in the poll and try to answer by all the students. Okay. Thank you so much.